Hello everyone, welcome to ICSE Physics, Keeping Intellectually Engaged. Today we are going to focus on the numerical sections of exercise 3B of your Selena publication textbook. Let us read the question. From the diagram given below, answer the questions that follow. Look at the picture. What kind of pulleys are A and B? Second, state the purpose of pulley B. Third, what effort has to be applied at C to just raise a load of 20 kg force, neglecting the weight of pulley A and friction? Neglecting the weight and friction, it's an ideal case. Let us try to solve the question. Look at the diagram drawn on the board. You can see a single movable pulley system with a fixed pulley at one end. A load is being attached. Okay, what's the first question? What kind of pulleys are A and B? Look at the pulley A. It is, you know that it's a movable pulley. It moves up and down, so pulley A is movable. What about pulley B? It is fixed to the rigid support with the help of a frame, you can see. So it's a fixed pulley. So first part of the question is solved. Coming to the second part. State the purpose of pulley B. For what purpose pulley B is attached here? So in a single movable pulley, we attach a single fixed pulley to change the direction of the effort applied. That is the only function of single fixed pulley, to change the direction of the effort applied. So pulley B changes the direction of effort applied. Changes the direction of effort applied. Right? Yes. Now the third part, what effort has to be applied here at the free end to lift up a load of 20 kg force? What is the effort to be applied here? So we have been given load and effort is not there, no other quantities are given there. For that purpose, let us assume that when the effort moves through a distance x in the downward direction, dE, displacement of effort, is equal to x. How much distance the load will move in the upward direction? We have studied in the previous topic that when the effort moves through a distance of x, the load will move through a distance of x by 2 in the upward direction. Okay, because you look at this pulley, movable pulley A. This is being supported by two segments of the rope. When the effort moves through a distance x in the downward direction, each segment of the rope moves through a distance of x by 2 and x by 2. Okay, as a result, the load will rise up to a distance x by 2. We know the formula, load into displacement of the load is equal to effort into displacement of the effort. Substituting the values here, load is equal to 20, dL is equal to x by 2, and dE is equal to, we don't know, and x is equal to dE is equal to x. So effort is equal to, we want to find out effort is equal to 20 into x is equal to 2Ex. Therefore E is equal to 20 by 2, and effort we are getting as 10 kg force. So the value of effort is 10 kg force. Steps are clear to you? Okay, right. Coming to the second question of this session, question number 2. A pulley system with a velocity ratio of 4 is used to lift a load of 150 kg force through a vertical height of 20 meter. The effort required is 50 kg force in the downward direction. Calculate the distance moved by the effort, the work done by the effort, the mechanical advantage, the efficiency of the pulley system, and the total number of pulleys and the number of pulleys in each block. There are 5 questions in this section. Let us read the question once again. A pulley system with a velocity ratio of 4. So what is the velocity ratio given? Velocity ratio is equal to 4. Let us try to find out the given quantity. Load is equal to 150 kg force. Is used to lift a load of 150 kg force through a vertical height of 20 meter. What is the distance of load? Is equal to 20 meter. These are the quantities given. Through a vertical height of 20 meter, the effort required is 50 kg force. Effort applied is 50 kgf, right? Okay. So 50 kgf, it is gravitational unit of force. We have to convert into Newton, multiplying it by 10, 50 into 10, that is equal to 500 Newton, right? Okay. The effort required 50 kilogram force in the downward direction. Calculate distance moved by the effort. We have to calculate distance moved by the effort. The first one, distance moved by the effort. Okay. So we know that velocity ratio is equal to distance of effort to distance of load. We know the formula. In order to solve numerical, all of you must be very thorough with the formulas given. That is equal to 4 is equal to, what is distance of effort? We have to find out by dl. What is dl? 20. 4 into 20, de is equal to 4 into 20, that is equal to 80 meter. Distance of effort or displacement of effort. So the first part is over. Coming to second part, the work done by the effort. What is the work done by the effort? Work done by the effort, WE, is equal to, what is that? Force into displacement. What is that formula? Effort into displacement of effort, of course. Therefore, effort is equal to 500 Newton into displacement of effort is equal to 80 meter. That is equal to 500, 5 8s are 40 to 3 zeros, right? Yes. Okay. 40,000 joule. Remember that the unit of work is joule. Second part is over. I hope these steps are clear to you. Moving to mechanical advantage, third part of the question, that is third part. Mechanical advantage. Mechanical advantage is equal to, all of you know the formula, load upon effort. Very simple. Load is given 150 divided by 50, that is equal to 3. Mechanical advantage is 3. It is a pure ratio, it has no unit. The fourth part of the question is, I am solving here. You have to calculate the efficiency. Efficiency eta. Efficiency eta is equal to mechanical advantage upon velocity ratio. You know the formula. All quantities are given. Efficiency is equal to mechanical advantage upon velocity ratio. What is mechanical advantage? 3. Velocity ratio 4 into 100. When we express efficiency, it is always expressed in percentage. That is equal to 25 3s are 75. Efficiency is equal to 75%. All right? Yes. Now the last part, the total number of pulleys and the number of pulleys in each block. The fifth part, total number of pulleys. How can I find out? No diagram is given there, but velocity ratio is there, right? Velocity ratio is equal to, how much you got? It is given there, velocity ratio is 4. So the total number of pulley will be, number of pulleys is equal to 4. When the number of pulleys is an even number, I have mentioned to you earlier that each block, the upper block and the lower block, will consist of equal number of pulleys, right? So the number of pulleys in each block will be, number of pulleys in each block will be 2. 2 plus 2. Okay? Yes. Now coming to the third question of this section. The diagram alongside shows a pulley arrangement. Look at the picture. Name the pulley A and B. In the diagram, mark the direction of tension in each strand of string. What is the purpose of the pulley B? If the tension T is T, deduce the relation between TE, E and L. What is the velocity ratio of the arrangement? Assuming that efficiency of system is 100%, what is the mechanical? Let us have a close look at the diagram given there. It is very important to understand the diagram given. So it's a single movable pulley system, right? Look at the diagram drawn on the board. You can see a movable pulley A and a fixed pulley B. It's a single movable pulley system, of course. Name the pulleys A and B, which we already discussed. Pulley A is movable pulley. Pulley B is fixed, which is used to change the direction of the effort applied. So name the pulleys A and B. We have named it. Second part, in the diagram, mark the tension, direction of tension on each strand of the string. So load is acting downward, that is the action force. The reaction force is nothing but it is a tension which is acting along the string in upward direction. T, you can see the tension is acting along the strings in the upward direction. So we have marked it clearly. Tension, remember that tension is always acting along the string in the upward direction. Okay, that part is over. So second part, we have marked the tension acting. Coming to third part of the question, what is the purpose of the pulley B? Pulley B is used to change the direction of the effort applied. Used to change the direction of effort E. Right? Yes, very simple. Now the fourth part. Coming to the fourth part of the question. If the tension is T, deduce the relation between T and E and L. Tension and E. What is the relation between tension and E? Again, look at the figure. So when the pulley is in equilibrium position, when it is not rotating, effort will be balanced by T. Therefore, E is equal to T. This is the relation between effort and tension. Then what is the relation between E and L? Effort and load. Load is equal to L is balanced by tension acting on the two segments, that is T plus T, that is equal to 2T, and effort is equal to T. So we can write L is equal to 2E because T is equal to E. Therefore effort is equal to, what is effort? Effort is equal to L by 2. Effort is half of the load, which I already discussed in the previous module. Effort required is half of the load. Okay. So effort is being reduced there. It acts as a force multiplier. Right. Now moving on to last part of the question. Assuming the efficiency of the system is 100%. Efficiency is 100%. When the efficiency is 100%, it's an ideal case. When efficiency is 100%, it's ideal case. What is the mechanical advantage? You have to find out an expression for mechanical advantage. Mechanical advantage is equal to L by E. What is L? L is equal to, yes, L is equal to 2T. Effort is equal to T. T cancel. So we are getting mechanical advantage as 2. The value of mechanical advantage is 2. Okay. So we got all the answers. All right? Yes. Let us read the question. In figure 3.32, draw a tackle to lift the load by applying the force in the downward direction. Mark in the diagram the direction of load and the effort. If the load is raised by 1 meter, through what distance will the effort move? State the number of strands of tackle supporting the load. What is the mechanical advantage of the system? These are the 4 questions given there. You have to first draw the tackle to lift the load. Now have a close look at the diagram drawn on the board. The first task is to draw a tackle to lift the load. So now let us try to pass the rope around the pulleys. It's already passed, just I make you understand. We have studied that when the number of pulleys are more in upper block than the lower block, we have to start from the hook of the upper block. Starting from here, the free one end is attached here. Number 1, pulley number 2, pulley number 3, pulley number 4, and pulley number 5, and we got the free end where you apply the effort. So we pass the rope around the pulleys such that all the pulleys are engaged, and we got a free end where we can apply the effort in the downward direction. Okay, that task is over. Mark in the diagram the direction of load and effort. The load is attached here at the lower block, and what is the direction of the load? Load is always acting downward. Okay, and effort is acting at the free end in the downward direction. Okay, L and E are marked. Next, state the number of strands of tackle supporting the load. So how many strands of rope are supporting the load? You can see that the load is balanced by how many segments? You can see 1, 2, 3, 4, 5. So load is balanced by tension acting along 1, 2, 3, 4, 5. 5 segments of the rope. So the number of segments of rope supporting the load will be, obviously it will be 5. Right? Yes. So it is marked. So what is the mechanical advantage? Mechanical advantage of this system, block and tackle pulley system consisting of 5 pulleys. Okay. Mechanical advantage is equal to load upon effort. Very simple. What is load? Load is equal to, load is supported by tension on 5 segments, that is 5T. 5T in equilibrium position, and effort is equal to T. Right? Yes. So mechanical advantage is equal to load upon effort, that is equal to 5T by T, that is equal to 5. So we got the value of mechanical advantage as 5. What about the velocity ratio? So velocity ratio is equal to, in a block and tackle pulley system, velocity ratio is always equal to number of segments supporting the load. How many segments are supporting the load? Very simple, 5. So we got the value of velocity ratio 5. Though it is not asked, we have calculated it. Right? All right. Now the last part, if the load is raised by 1 meter, if the load is raised by 1 meter in the upward direction, what distance will the effort move? What will be the displacement of effort here in the downward direction? Okay? Okay. Now we have the formula, velocity ratio is equal to displacement of effort upon displacement of load. We know the formula. All of you must learn the formula. You have to apply, you should learn to apply suitable formula in the circumstances. Okay. Velocity ratio is equal to 5. What is displacement of effort? That you have to calculate. What is displacement of load? 1. Therefore, displacement of effort is equal to 5 meter. So effort moves through a distance of 5 meter. All right. Steps are clear to you. So we have attempted all the part of this question. That's all for today's session. Thanks for watching ICSE Physics, keeping intellectually engaged. Thank you very much. Stay tuned for more interesting video to come up.